students, welcome to class 18th. Okay, so in the previous class we have learned regarding the oxidative addition, reductive elimination, beta hydride elimination or transfer, like this. Okay, so today we'll go for the further concepts of this all the criteria here. Okay, so in some case it comes as I said in today's Zoom meeting, that binuclear. So binuclear oxidative addition. Okay, so what is this? So it is nothing but one electron change. Okay, one electron exchange between the metals. One electron exchange between the metals. For example, if you take this cobalt, which is in 2 state, okay, with pentacyanide, and react with the alkyl halide here, so what will happen now? You can take it as alkyl R going and attacking here CO, and this will change to +3 and CN5. okay, 3 minus plus X, you can take it here CO, this becomes again +3 CN5 minus 3. Okay, like this minus 3. Okay, so this is how we say is a binuclear oxidative addition, where this alkyl halide RX is added into this two molecules of this complex here. Okay, so here you can see here, so one electron is shared between these two metals. So here one electron, so like this. So this is how this type of reactions we call it as a binuclear oxidative addition. Okay, so this is what you keep in the mind. So all the factors you have to keep in the mind and make up points of all these things, so that this all it will help for the inclusion in the some of the net examination problems whenever we solve this. Okay, so one more the beta hydride elimination. So this thing you have to keep in the mind, that beta hydride elimination already have told you. So this is possible or given by 16 electron species. Okay, so 16 electron species is a possible here. And second one is there is a removal of alkene. Okay, so there is a removal of the alkene. This way you have to keep in the you have to make a points for all the things. What is the criteria for beta hydride oxidative reductive elimination, sigma metathesis, whatever the terms comes in this concept of organometallic, you have to make like this. Okay, so that will help you in solving the net problems. Okay, then what is that electron count here? So that is one thing, electron count here increases by 2 units. Okay, so no doubt beta hydride elimination is there, so this will happen, and even the electron count here increases by the 2 units, and usually these are more faster. Okay, for D2 or higher transition elements or higher transition elements. So this thing you have to, I think I have told these points in the previous videos, but also you may remember here because we'll solve this some problems from net examination. So this is what it is very faster for the D2 or higher transition elements. Then if you say of D0 or D0 or the main group element alkyl complexes, okay, or main group elements complexes, okay, alkyl complex, if you see this, so this is faster in D2 and higher transition elements rather than D0, or many it is happening but very slow here. So conditions is availed here in this condition. Okay, now beta hydride elimination. So this is what we have learned regarding this. Okay, now let me see whether if in some cases if they give this like this CH2, okay, C CH3 CH3 CH3. Okay, now if this is the possible, if this is a case of some of the one of the complex here, and beta hydride elimination concept is coming into this. Is it possible? You have to see here. So this is, if metal is there, this is alpha, this is beta. Okay, so as such there is no as such beta hydride here, so therefore beta hydride elimination is not possible here. So it is not possible because there is no beta hydride elimination. Beta hydride is not there here, so there is no hydrogen as such in beta carbon here, so that's why this is not possible here. Okay, fine. Now like in this case also sometimes they give you CH2 pH. Okay, so there will be, or you take it as carbon only and divide by 3 phenyl group like this. Okay. So here also there is what no beta hydrogen is there, so that's why in this case also there is no as such beta elimination is not possible here. Okay, so this thing you have to keep in the mind. So what is the speciality of this beta hydrogen? If it is there, there is a chance of elimination, otherwise it is not possible. In these two cases it is not possible. Sometimes you will see we will see that this type of Bornin type of like this. Okay, and there is a metal here like this. Okay, now this carbon is alpha, so this becomes beta and this becomes beta, and there is a hydrogen here. Okay, now is the beta hydride elimination possible in such type of compounds? In the examination they give. Okay, so four molecules will be there, you have to which is the fastest or which is a stable complex, like this they will ask. Now this is a complex he has given, so whether the beta hydride elimination is possible in this? Definitely here, here there is a hydrogen here, but what happens if you remove the what do you say if you remove the uh, hydrogen from here, so you are ending with the alkene here, like double bond here in this case. Okay, now this case what is happening, it is this compounds formation, the of double bond in this case with the metal here is highly unstable. Okay, so this is highly unstable, so this is not possible. That's why no doubt there is a beta hydrogen here in this complex, but elimination is not going to take place here because the formation of this compound is unstable. So that's why this is not going to form the complex. As similarly we have seen that this type of complex, if you see here, okay, so like this, so this is hydrogen, this is hydrogen, like this. Okay, so if this is a metal, this is alpha beta, so beta has hydrogen here, so definitely sometimes they give this way, see these two do have taken here, so this also is not possible, here also it is not possible. So you may confuse, hydrogen is there, yes definitely you may have, this is the most unstable. So your beta hydride elimination can take place from here like this, but that is no possible here because you can see here, if you see the hydrogen, it's to eliminate this, it is very far from the metal also, and it's not and the whatever the product I'm going to form here is will be unstable here. This is the most stable form itself, I can say. And if we try to remove this hydride, which is a very far distance from this metal, is going to give for unstable type of product, and that's why this is also not possible here. Similarly, if you take beta hydride elimination for tertiary butyl compound, let me see, if this is carbon and here like this CH3 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 this way. Okay, so this is tertiary butyl, so tertiary butyl. Okay, so is it possible here in this case? Okay, this also is not possible, even if there is some if possibility of hydrogen is there, and here if you see that some of the bulky compounds are present here, some other compounds, so it is also not possible because of steric hindrance, because of steric hindrance. That's why the tertiary butyl or isopropyl. Okay, uh, because though it is having it is not like isopropyl, if we take, so I will take this as a carbon here, and CH3 I will take H CH3. Okay, so this compound is what isopropyl. Okay, now if you take here isopropyl compound, and if you say that whether the beta hydride elimination, so definitely, so here this is alpha and this is a beta, you can take alpha beta beta, so definitely beta, there is a, like here isopropyl, you can say that beta alpha beta, so beta will be there here. So but also it is not possible because of steric hindrance of CH3 CH3 CH3, so butyl, so it's not possible. So here also same thing here, so definitely beta hydrogen is there, but because of steric hindrance, what will happen, because of steric hindrance, the beta elimination is not possible. So like this you have to keep in the mind. Okay, similarly let me see one more compound. If I take here, so I will take this compound CH3 four times. Okay, tetramethyl titanium here. Now what will happen, so this is possible beta hydride elimination definitely. So you can see here CH3 four times is there. Okay, CH3 CH3 like that. Okay, now if you see here, so your titanium is plus 4 state, plus 4 means D0 system, and as I said in the previous points to be noted for beta hydride elimination, that G0 there is no beta hydride elimination is not possible. Okay, so this is a D0 system, and you can see that and there is no free coordination site at all here. So all titanium is all four side, it is this one, so free coordination site is absent here. Okay, and that's why no beta hydride elimination is possible in this compound also. Okay, these all problems, these all complexes, these all molecules will be given in the net examination, and they may ask for beta hydride elimination concept. So these things you have to keep in the mind. So this will definitely help you. Okay, so now if you see like compound like this one. Okay, so if I take it as CH3, okay, try CH2 titanium, like this. Okay, now and if you, I will take here once again one more complex here, CH3 twice CH2 titanium, like this. Okay, and now now if you see these two compounds, okay, here there is like this, and it is here in this way. And if a question asks a question is asked that which is more stable here, so which is stability of the, which is more here, like this something, if they ask the question here, so you can see here which is more stable here. Now you have to guess it here. So now you can see here, this is alpha, this is beta, so there is no beta hydrogen in here in this complex. Okay, so elimination is not possible, so this becomes more stable. Okay, so this is compound is more stable than this. So now here alpha beta, so you can see here hydrogen is there, so hydrogen can be eliminated in this case. Okay, so that is what compared to this, so this becomes highly stable a molecule. Okay, so here why it is not why it is stable, because there is no possibility of beta hydride elimination. So this type of question also is asked sometimes, so you can make a note of this point also. Okay, similarly they will ask you to identify the increasing ability, increasing, I will write here, increasing order, okay, increasing stability order, something like that, according of the organic compound. So they will give some organic compound, and they will ask the increasing stability. Okay, so like this they may give you TiMe4, okay, B TiCH2PH 4 times, okay, TiIPr 4 times TiET4, like this. Okay, now you have to see 1 to A, B, C and D, like this they have given. Okay, now you have to see stability of which is more here, like this. So increasing order of the stability you have to put, which is more stable and which is least stable, like this they are asking. Okay, so now see all the concept you can write, whatever we have written in the above, that concept you can do here. So in this all concept, which is a very least, I can say, unstable here. Okay, very unstable, you can see here, this case will be very unstable, ET4. Okay, ethyl tetraethyl, because CH2 CH3, so alpha beta, so beta hydride elimination is possible in this case. Okay, so that is what it becomes a very least stable here. So next you can think of like this. Okay, then methyl is there, TiMe4 is there here. So TiMe4, this also becomes very followed by isopropyl, isopropyl, and finally the most this stable will be your this compound. Okay, TiCH2, okay, PH4 times, like this. Okay, the most stable compound will be this compound. Okay, CH2 PH4 times, TiCH2 PH4 times. Okay, so like here what we had previously, we have, I think I have taken the example there. Okay, so like this this was the 4 given in the 4 compound given, and the increasing stability was been asked. So this is what I think. So TiCH2 is the most stable, followed by this compound. Okay, isopropyl compound, because of because of the steric hindrance here. So what happens here, steric hindrance is more here, and that's why there is beta hydride elimination is not possible. Okay, and then followed by this compound, and lastly this compound. Okay, ethyl titanium tetramethyl then ethyl group. So this is the reason. This is what we can say, that with respect to beta hydride elimination, this order could be made. Okay, so this was the question asked in one of the examination. So you can also try on this and enjoy how this order has come, and how nicely the beta hydride elimination versus stability of the complex could be arranged in this case. Okay, so like this. So like this, you can see that this is going to happen. So sometimes if they ask a very highly unstable complex like this, highly unstable or stable, highly unstable compound of which is highly unstable, they give like this: TiC2 H5 4 times, TiCH2 pH 4 times, PbCH3 4 times, like this. Okay, so highly unstable, highly stable. Now you can do it here. So this work you can do yeah, in the home. So I already have given you highly stable is I have given you here. This is a highly stable. This is a highly stable I have given because of steric hindrance is there. Okay, so unstable you can see. So these two are there. So you can see this is a yeah. So C2H5. So he has asked stable. So you can give this. Okay, unstable means you can work on to this, and you can tell me on the Zoom meeting. So which is highly unstable among these two? Okay, among these three. So you can go through this and you can tell me or comment me, or you can tell me in the Zoom meeting. So let me see how you work on this unstable compound. Okay, so this is what about some of the concepts. Okay, so they will be asking in the examination. Now one more thing we'll take into consideration. Yes, now one more thing they have asked in the examination, that they have given this compound like this: cobalt CD3 CD3 PME3. So there is a complex of this cobalt here with deuterated carbon CD3 methyl group, but deuterated methyl group here, and PME3 trimethyl phosphine is there, and he has given with alkene like this, treated with the alkene. Okay, one of the portion, and he has given already the compound. Okay, so what he is going to get? Okay, so this is one plus CD3H plus question mark. So this is what he has given. So a he has already given in the paper that question, that this is one he is going to obtain A, this is one he is going to obtain B, what is C he is asking. So what may be the C? He will give 4 options, and you have to find out what after this reaction what I am going to get this here. So very beautiful questions. So this is what we have learnt in the textbook wise. It's okay, but if it comes in this way in the examination, how you are going to solve? It's very difficult unless you are having the strong concept on the oxidative addition, reductive eliminations, all the things 4 to 5. Then only you can solve such questions here. Okay, so what will be the answer? So you can try. So I'm not giving all the things directly. I will go for the mechanism, this one. So if I get in this way, so this is cobalt and this is CD3 CD3 and PME3. Now you can see here, so cobalt we are having 9 valence electron, then this is 5 5 electrons from this 5. Okay, and this is 1 electron, this is 1 electron, and this is going to give you PME3. Now donate you 2 electrons here. Okay, so how many total electrons you have to see? This becomes 9 10 11 12 13 14 15 16 17 18 electrons. So this become now 18 electron species. Okay, now what will happen? Now he has given already alkene is been added here. So when alkene is been added, what will happen now? So it will add here. So now I will give it here like this, CO will be there. Okay, now this alkene will be added in this way as usual. CD3 PME3 will be there. Okay, when this is added in this 18 electron species, that means what it becomes now? It becomes a 20 electron species. See, 20 electron species. Now what will happen? Now you have the knowledge of what? Migratory insertion. When alkene is there, so there will be migratory insertion into this alkene, and what will happen now? You will get this compound CD3 will migrate here. So like this, CD3, and here one CD3 will be there, here one PME3 will be there. Now this CD3 is migrated here, so you are going to get here like this. Okay, one migrated CD3 will be there, and again it will become now 18 electron species here. Okay, so from 20 electron, again it becomes 18 electron species. Okay, now again it is going to react with your alkenes. Okay, so see the mechanism how nice it is. So again it is going to react with the alkene now here. So I will, cobalt is there already. I have taken this in this way, CD3. Now this is going to this will be added here, one alkene will be added here. This is already in this case whatever is there, and here CD3 is there, and along with the CD3, so there is one more PME3. Okay, so this is going to happen here. Now now what will happen here, this is what, again it becomes now 20 electron species. Okay, again it becomes 20 electron species from 18. Now here there is a mechanism now. Okay, so here what will happen now, see, like this I will put. Okay, now what will happen here, so very keenly you can, so there is a hydrogen here. Okay, so what will happen, this bond will broke here like this. Okay, this bond will broke here, this hydrogen will go in the form of hydride like this. Okay, this will come here like this. Okay, and this will go in the form of hydride, and this CD3. Okay, so this will go here like this, like this, like this. Okay, now see, this CD3 is out here, and this is hydride is out. See, both they are going to react to form CD3H plus. Now what will happen, this, now this bond is released here, this bond is released here like this, so it becomes no double bond like this, and here CD3 is attached like this. Okay, CD3 is attached, and finally you get here what, plus you get here this compound as usual like this, CD3 you get here, and you are going to get this compound. What is left now, so I will write here, that is your CO, one alkene is this, and PME3 like this. Okay, see here, this is a main mechanism here now. So this thing you have to, this mechanism you have to keep in the mind. So this bond, so this bond goes here, this bond goes here like this bond comes here like this, and this hydrogen goes here like this. Right, this is cyclic mechanism takes place here. So cobalt takes the electron here because 20 electron system species is there. So cobalt because it requires the 18 electron system, so one has to go out here. Okay, so that's why this mechanism takes place here, where this CD3 is out here by giving the electron here like this, and this whole thing will be out here by this like this. Okay, so double bond will be there here, and this hydrogen will be off here, so this will get like this, double bond CD3. Okay, so here I have written double bond CD3, CD3H, this H and this CD3 will form CD3H, and remaining part is what, this cyclopentane cobalt and this alkene and PME3. So you get this cobalt, alkene and PME3. See, this is the mechanism. Now you see the top question what he has asked. Now if you see this question, so what is the C he has asked? So CD3H he has given, this he has given, see, PME3. Okay, this he has given. Now this or this, so remaining what is now C? So C is nothing but your this compound. What is that? Left is what, your C is nothing but your this compound. What is that? This compound. So this is your C, this CD3. So this is your this C compound. Okay, so this is how we have to solve the solve this. This is your compound C. Okay, this will be given in the options, so you have to take this like this here. So that is what I wanted to show here. So see here, so after learning this oxidative addition, reductive elimination, whatever it may be, so we are very happy. What is oxidative addition? You nothing, as in the Zoom you say it is addition of CH3, like your today's one complex we learned, sir, CH3 we added, and this is what. So electron, see, we cannot do that also in home. Lot of time will be there, you have to count the electrons, everything. Still you are not able to see which electron species cobalt 1 to cobalt 3 has there. So PPH3, how it gets removed from this, all thing you have to work at the home correctly, then so you will not do. So that much confusing way the net problems will be. Now this you see. Okay, so this is one type. So just meager textbook concepts of the oxidation reductive will not help you. That will only, you can increase the score in the examinations, okay, by highlighting and all. But see this problem, is it right? So a lot of mechanism is involved in this problem. So where you can see the electron, how it changes from 18 to 20, from 20 to 18, again 18 to 20, again 22. So this all thing is very much important. Is it right? It's not so simple. So this is what very you should be strong in this electron count also. So whatever examples we all learned in the previous videos also, be strong in electron count. Okay, in some cases you say 14, in some cases you say 18. In one cases you include this PME3 as a 2 electron. In one cases we say that it's a neutral ligand. So these all things you have to keep in the mind. There should not be any confusion in solving in getting into this into account. Is it right? So today's one question in the Zoom, what we PME3, I said it's a neutral. Okay, then Ravi said it's a 2 electrons, sir, so he brought to 18 electron. So this should not happen. So there should not be confusion. Clear cut concept should be there, and problem is very much important. What way the problem is asked, in that we have to solve. Is it right? You have to turn your all the things as per the problems. What is the question? You should not be in a hard fast with one concept. Idu ಈ ಥರ ಏನಿದೆ, so this should happen. Not like that. Okay, you have to see the question and set your answers in that way. Then only the concepts, the whole thing will be in the correct way. Okay, hope you understood this today's video. Okay, let me see if any other problems if I get into the concepts of this, so we will add in the next video. Okay, so make a notes on this, and if any doubts is there, we will meet in the Zoom on Wednesday. Thank you.